Okay, solving quadratic equations, and we're using the factoring method. Let's look at the first example. So we're expected to solve x squared plus 4x minus 5 is equal to 0. X squared plus 4x minus 5 is equal to 0. I'm going to split the board into two. So the first thing you need to do is identify your A, your B, and your C. Okay? Identify your A, your B, and your C. So for this equation, what is our A? Remember, we said the A is the coefficient of x squared. So here we have x squared. We don't have any number in front of x squared. So when we don't have any number in front of a variable, we know that the number there is 1. So that means the value of A is equal to plus 1. I like to put the signs so I don't make mistake. And B is the coefficient of x. So B is plus 4. And C is the constant, the number without a variable. C is equal to minus 5. The next thing we're going to do is we're going to look for two numbers. Now, in a previous lesson where I taught about factorization by grouping, for you to factorize by grouping, you need to have 4 terms. But here we have 1, 2, 3 terms. So what we want to do at this point is to split this middle term into 2, so that one of it is going to go with x squared, and the other part of it is going to go with minus 5. So our target is to split plus 4x into 2. For us to do that, we are going to look for two numbers that will multiply themselves to give us AC. So we are looking for two numbers that will multiply themselves to give us AC. Remember, A is plus 1, C is minus 5. And those same two numbers will add to give us B. So we look for two numbers that will multiply to give us AC, and those same two numbers have to add each other to give us B. What is AC? AC is 1 multiplied by minus 5. 1 multiplied by minus 5 is going to give us minus 5. And B is equal to plus 4. So this means we are looking for two numbers that will multiply themselves to give us minus 5. And those same two numbers will add themselves to give us plus 4. So let's see the numbers that will multiply themselves to give us minus 5. We have plus 1 multiplied by minus 5. This will give us minus 5. And we have minus 1 multiplied by plus 5. These two values will multiply themselves to give us minus 5. But out of these two values, which one is going to add to give us plus 4? Plus 1 minus 5 is going to give us minus 4. Minus 1 plus 5 is going to give us plus 4. So that means this is the value we are looking for, because they multiply to give us minus 5 and they add each other to give us plus 4. So we're going to use these two numbers to replace plus 4x. So instead of having plus 4x, we're going to have minus x. Remember, minus x is the same thing as minus 1x plus 5x. So as I said earlier, we are trying to split this number into 2. So now we have been able to do that. So plus 4x is the same thing as minus x plus 5x. If you check it, it's going to give you plus 4x. So we're going to use these these two terms to replace this one term. So we are going to have x squared minus x plus 5x minus 5 is equal to 0. So we can see that these two terms have replaced this term, right? Our target is to produce 4 terms so that we can factorize these two together and then factorize these two together. Okay, so let's factorize these two together. X squared minus x, what is common? X is common. X squared divided by x is going to give us x. Minus x divided by x is going to give us minus 1. So this plus sign is here. We bring it down. 5x and 5, what is common is 5. Plus 5x divided by plus 5. Plus 5 and 5 will cancel each other out. So we have x Minus divided by plus will give us minus. 5 divided by 5 is going to give us 1. It's equal to 0. Next, we bring the values outside the bracket together. X plus 5. Since these two values are the same, we'll pick one of them. X minus 1 is equal to 0. So finally, we equate each of the values in the brackets to 0. So we have x plus 5 is equal to 0, or x minus 1 is equal to 0. So from what we've learned in basic equation, when plus 5 crosses over the equal to sign, it becomes minus 5. So x is equal to minus 5, or when minus 1 crosses the equal to sign, it becomes plus. So x is equal to 1. So these are the two values of x. This means these are the two values that makes the left side of this equation equal to the right side of this equation. So we call this the solution to the quadratic equation, or the roots of the quadratic equation. These are the values of x when y is equal to 0. Okay, let's look at the next example. X squared minus 2x is equal to 15. X squared minus 2x is equal to 15. So in this particular question, if we compare it to the basic form of a quadratic equation, we have ax squared plus bx plus c is equal to 0. So comparing this to this, we observe that our c, which is the constant, is on the right side. So first thing we need to do when we are solving using the factoring method, okay, this does not apply when you are using the completing the square method. When you're using the factoring method, you have to bring this c over to the left. This will become x squared minus 2x. The 15 crossing over the equal to sign is going to be minus 15. So that's the first thing we need to do. The next thing we need to do, we need to identify our a, b, and c. So our a, which is the coefficient of x squared, is equal to plus 1. Our b is equal to minus 2. And our c is equal to minus 15. Okay. Okay. So we are looking for two numbers that will multiply themselves to give us AC and then add themselves to give us B. So what's our AC? Plus 1 multiplied by minus 15. Plus 1 multiplied by minus 15 is minus 15. And then B is minus 2. So we're going to write down all the numbers that will multiply themselves to give us minus 15. We always start from 1. To make your job easy, start from 1. So plus 1 times minus 15. If you multiply them, they'll give you minus 15. Minus 1 times plus 15 will also give you minus 15. Also, plus 3 times minus 5 will give you minus 15. Minus 3 times plus 5 will give you minus 15. So all these values will multiply themselves to give you minus 15. But we are looking for the one that will also add themselves to give you minus 2. So let's see. Plus 1 minus 15 will give us minus 14. Plus 1 minus 15 will give us minus 14. Minus 1 plus 15 will give us plus 14. Plus 3 minus 15 will give us minus 2. And plus 3 minus 5 will give us minus 2. Minus 3 plus 5 will give us plus 2. So among the numbers, this is the combination we are looking for. The combination is plus 3 and minus 5. So we are going to replace minus 2x with plus 3x minus 5x. So that's what we're going to use to replace it. So we have x squared minus 3x plus 5x minus 15 is equal to 0. So we have replaced minus 2x with these two values. Oh, sorry, it's supposed to be plus. plus minus. Okay. So next, we're going to factorize these two together, and we're going to factorize these two together. So let's factorize this. Between x squared and plus 3, what is common is x. So we have x squared divided by x will give us x, plus 3x divided by x will give us plus 3. So this minus sign we have here, you bring it down. 5x and 15, what is common is 5. Minus 5x divided by minus 5. Minus 5 will cancel out minus 5. We have x. Minus 15 divided by minus 5. Minus divided by minus is plus. 15 divided by 5 is 3. So to know that you're on the right track, the value in this bracket must be the same as the value in this bracket. If they are different, then there is an issue with the process you've undertaken. So next, you bring the values outside the bracket together. So you have x minus 5, and you pick one of these two. So you equate each of the values to 0. So x minus 5 is equal to 0, or x plus 3 is equal to 0. So at this point, you simply move the minus 5 to the right, and it becomes plus 5. So x is equal to 5, or if you move plus 3 to the right, it becomes minus 3. X is equal to minus 3. So these are the solutions to the quadratic equation. This means these are the values of x when y is equal to 0. One more example. We actually have two examples, but the last example will show us that there are some questions you cannot solve using the factoring method. Okay, the next example is x squared minus 49 is equal to 0. So is this a quadratic equation? At the beginning, we agreed that a quadratic equation is an algebraic equation of the second degree. So how do you know a quadratic equation? It's when the equation is of a second degree. That means the maximum exponent of the variable is 2. So over here, we have a variable x. The exponent here is 2. So since 2 is the maximum exponent, this means this is a quadratic equation. It doesn't have to look like the previous examples that we've done. So once you can see that the maximum exponent is 2, that is a quadratic equation. But here, we don't have b. We only have a and c. So we cannot go ahead to solve it the way we did for the first two examples. But there is another way of solving, or there's another way of factorizing. Remember, we are looking at factoring method. So when you have a situation like this, there's another way of factoring. It's called difference of two squares. Difference of two squares. So here we have difference, which is subtraction. Here we have a squared value, x squared. But over here, we don't have a squared value. 49 is not a squared value, but we can convert it to a square because 49 is a perfect square. A perfect square is a number whose square root is a whole number. So instead of having 49, we can simply have x squared minus 7 squared is equal to 0. Because 7 squared is 49. 7 multiplied by 7 is 49. So we can replace 49 with 7 squared. And the principle of factorization using difference of two squares simply states that when you have a squared value, subtracting a squared value, all you need to do to factorize is open two brackets. In the first bracket, you add these two bases, so you have x plus 7. And in the second bracket, you subtract x minus 7 is equal to 0. So now you can equate this to 0. So x plus 7 is equal to 0, or x minus 7 is equal to 0. So moving plus 7 to the right, it becomes minus 7. So x is equal to minus 7. Or moving minus 7 to the right, it becomes plus. X is equal to plus. Or we can just put it is equal to 7. So these are the possible values of x. So x is equal to minus 7 and x is equal to plus 7. Okay, so let's continue. Let's continue. So we have one more example. So this example will show us that not all quadratic equations can be solved using the factoring method. Let's see. So here we are told to solve the quadratic equation below. X squared plus 5x minus 7 is equal to 0. When solving this, as we said, you're going to look for the value of A, you're going to look for the value of B, and you're going to look for the value of C. Okay. Remember, we're using the factoring method. So A is equal to 1 or plus 1. B is equal to plus 5. And C is equal to minus 7. Okay. So we've gotten the values for A, B, and C. The next thing we're going to look for is look for numbers that will multiply themselves to give us AC and add to give us B. What is AC? AC is plus 1 multiplied by minus 7. That will give us minus 7. And B is plus 5. Okay. So now let's look for the numbers that will multiply themselves to give us minus 7. We have plus 1 times minus 7 minus 1 times plus 7. So these two numbers will multiply themselves to give us minus 7. But will they add themselves to give us plus 5? Plus 1 minus 7 will give us minus 6. Minus 1 plus 7 will give us plus 6. So none of this combination can both multiply themselves to give us AC and add themselves to give us B. This means this question cannot be solved using the factoring method, right? It cannot be solved using the factoring method. Once you cannot have two numbers that will multiply themselves to give us AC, and those same two numbers will add themselves to give B, that means you cannot use the factoring method to solve that question. Although you can use the formula method to solve it, you can also use the completing the square to solve it. But we cannot use the factoring method to solve this. Okay? So that brings us to the end of this lesson.